Good evening, good afternoon, good morning, wherever you may be, and welcome to our today's webinar. Save more than $10,000 when deploying SQL Server failover clustered instances on Microsoft Azure. Webinar is brought to you by Starwind Software. My name is Max. I'm the product manager with Starwind Software, and our featured speaker for today is Edwin Sarmiento. Edwin, your turn.
Thanks everyone for attending this webinar. This will be focused on deploying SQL Server failover clustered instances on Microsoft Azure. I want to thank Starwind Software for giving me the opportunity to do this, as well as you folks who are attending. Feel free to post in questions on the chat window as we're moving along. If you have any questions with regards to Starwind Software, Microsoft Azure, SQL Server, failover clustered instances, and high availability on the cloud. Max already made that introduction about me. My name is Edwin Sarmiento. I'm a Microsoft MVP and a Microsoft Certified Master on SQL Server. I blog on a regular basis on my site. You can also get in touch with me through Twitter, LinkedIn, send me a direct email. And as I mentioned, I totally encourage you to post questions during the presentation. I'll be more than happy to answer those questions for you. We'll be dedicating some time at the end of the webinar to address those questions. Now, the whole topic revolves around working with Microsoft Azure. Now, I don't know if many of you have started working with Azure, or Microsoft Azure initially was called Windows Azure, but when Microsoft introduced the concept, they first started off with platform as a service, and this is where all of the applications are hosted, and eventually they've moved into the platform, or rather infrastructure as a service. The focus of this presentation will be around infrastructure as a service and building infrastructures in Azure, particularly SQL Server failover clustered instances. And I'd like to tell a story about how building infrastructures on Microsoft Azure is similar in concept to immigration, or moving from one country or your home country to another. I still consider myself relatively new up here in Canada, was in Singapore prior to moving here, but I'm originally from the Philippines. But whenever somebody moves to a different country or migrates to a different country, you gotta decide for yourself, well, if I'm moving, am I moving because I want a better way of life, or because there's a job offer? And when there is a need for me to move, I gotta ask myself, well, what do I need to bring for myself? And of course, you can take your family with you, like what I did, or you could do it on your own, but you have to decide what you need to bring for yourself. And there's a couple of questions that you need to ask. And these questions will determine how you could move forward with your immigration or migration. One of the questions that I asked when I was in this process is, well, I don't have a computer science degree, I don't have a computer background. Can I use my existing skills, or can I use what I know to find a job, to get settled in, and eventually be stable in the new environment or in the new community? Or do I need to go back to school and start learning new skills? Like when I moved to Singapore, the first thing I asked was, can I use English as a mode of communication, or do I need to learn a bit of Mandarin? Same thing when I moved here on the eastern side of Canada. Do I need to learn how to speak French in order to interact with people, or can I just use English? It's one of those questions that I ask, and most people who are moving to different countries, it's one of those questions that they ask. Another thing, or another question that you may start thinking about is, well, what about my lifestyle, my personal lifestyle? I'm moving to a different country. There are some specific lifestyles that I maintain. Can I take them with me, or can I apply them when I move to a different country? One of the experiences that I will never forget is when I moved up here in Canada in 2008. You know, like what every new immigrant does first time they land into a new country is they open up a bank account. And because, banking is way different in Singapore than in Canada, the first thing that I asked was, how do you deal with online banking? Is there such a thing as a two-factor authentication? And I was carrying with me a couple of RSA tokens for my online banking. It's not the same thing because they haven't introduced that yet back in the days. And I also asked about, well, what about credit cards? Do you have chips in your credit cards for enhanced security? And again, they still don't have that. Can I take those lifestyle with me? Do I adjust to the way of living, or can I bring some of those with me? Or do I just stick with something that's common across all countries, like maybe going to the public library and read books? You also need to ask, in my case, I need to ask, well, if I need to move there, do I rent an apartment, or do I buy a house at some point, maybe get stabilized? What I did was, the first year I rented an apartment, build some cash flow, and then at the end of the first year, we decided, let's just buy a house and just put the money in for the mortgage. These are some of the questions that we asked when we moved to different countries as part of the immigration process. And of course, that entails money. And it's no different. Why am I tying this back to building infrastructures in Microsoft Azure? Because here's the thing, as IT professionals, there's all this buzzword on moving to the cloud, and it's been going on for the past couple of years. And with physical data centers that we manage, the CTO or the CIO decides, let's try to evaluate how we can move to the cloud, maybe take advantage of some of the benefits that the cloud offering or is offering. We ask the same questions as IT professionals. And like I said, it's no different. It's those same questions. Can I use my existing skill set? As a SQL Server guy or a SQL Server professional, I know that I will still be able to use, T-SQL querying or performance tuning for databases, but do I need to learn new skills? As far as I'm concerned, I needed to learn a lot of networking. Maybe something that a typical SQL Server professional does not get exposed into, especially if you're a dedicated SQL Server professional working with just performance tuning or application development or infrastructure. But I needed to learn a lot of networking skills because everything is abstracted for me, and Microsoft takes care of those things for me. One skill that I have to really brush up on is PowerShell scripting, because a lot of the things that can be done on Microsoft Azure can only be done using Windows PowerShell. And this is a big advantage, especially if you already know how to write PowerShell scripts, because you're simply going to take into account whatever you've learned as far as writing PowerShell scripts are concerned, and translating those to using Azure PowerShell modules to build your VMs, configure networking and routing, and how all of those applications built into Azure and the infrastructure as a service offering. Can I take my existing technology is another question that not just IT professionals ask, but also CTOs and CIOs, because, well, a typical example is this. I have a hardware security module for my SQL Server database to protect those databases. Do I have something like that on the cloud, whether it's Azure or Amazon or any other cloud provider? If I have a custom application or a custom hardware or a custom technology that I use on premise, is it easy to move that over to Azure? And again, that's just one of those questions that we ask. The more important question that the CFO, the CIOs, and even the CTOs ask is, can I afford the cost? In fact, this has become the linchpin of how a lot of organizations started moving to the cloud, because, well, as IT professionals or even as SQL Server professionals, we kind of ask the question, Is it just buying hardware and buying the license? But more often than not, the capital expenditures go, or the overall expenditures go above and beyond the capital expenditures. Well, I'm simply referring to operational expenditures in terms of, well, what about air conditioning and ventilation for those physical servers? What about power consumption? What about engineers that need to maintain the physical infrastructure or the data center that we need? And because the cloud has provided the opportunity to just, I'm only going to pay for something that I need and I use. That has become, again, the rationale why a lot of these organizations started evaluating the cloud, even for proof of concept deployments. But as a SQL Server guy, as somebody who specialized in high availability and disaster recovery, particularly for SQL Server workloads, this is my biggest concern. Why my biggest concern? Well, I know the cloud has promised a lot of high availability and disaster recovery and redundancy, geo-replication across different regions, not just in North America, but worldwide with their data centers spread across the globe. I'm still concerned about, well, that's just one aspect of it. What about local availability? And when I mean local availability, I wanted it to work in terms of my application and my database service working within the same locality. And when something happens, my database is still able to fail over to another machine, much like how failover clustering works within the same locality. I just don't like the idea of, well, my application is on the East Coast and then my database is on the West Coast. I need something like that. And why am I concerned about this? Because if you look at this specific MSDN article on high availability and disaster recovery for SQL Server in Azure virtual machines, it outlines all of these different options and features that are supported with using Azure virtual machines for SQL Server. Let me just highlight one through the first two ones: availability groups and database mirroring. Whatever you choose to include or implement as part of your high availability and disaster recovery option in Azure, it always has to go back to what your service level agreements are and what your recovery objectives are. And I'm picking the first two because high availability and my service level agreements are very tight, and I need close to zero recovery objectives. But the one thing that I it's something that I've been highlighting ever since I've started using and talking about availability groups. For one, it's an enterprise only feature. What that means is if I need to deploy a SQL Server workload on Azure and I want it to be highly available, it's going to cost me something, because Enterprise Edition is definitely the top layer edition which means I need to pay for top dollars in order for me to do that. And it's expensive just building even a 2 replica availability group, much more increasing the number of availability group replica in your architecture. Now, you might be thinking, what about database mirroring? I still recommend database mirroring because it's still supported. But unfortunately, it's been deprecated since SQL Server 2012. Now, again, you can use that, you can implement that, but at the end of the day, you need to plan how you can move away from database mirroring. And the reason why I really recommend database mirroring is primarily because, well, it's supported in Standard Edition. And if you're running SQL Server in Standard Edition, well, you can go ahead and use that as a way to achieve higher availability and fault tolerance within SQL Server, whether it's on-premise or on the cloud, in this particular case on Azure. Now, the question is, can we run highly available SQL Server workloads on Azure? The answer is yes. It's really all about how much you're willing to pay for and how much you can afford. So let's quickly look at how you can connect to a SQL Server failover clustered instance. Well, wait a second. Didn't you just talk about availability groups and database mirroring? Why are you showing failover clustered instance? Well, let's just take a look at a quick demo at this point, just to illustrate the fact. Let me connect to my Windows 7 workstation, and this workstation is connected to a SQL Server instance, a failover clustered instance running on Azure. If you take a look at my server name is in the form of a fully qualified DNS name, SQL failover-ems.cloudapp.net, and I'm using, oh, it doesn't say that there. I'm using my account, my domain account on Azure to connect to the database. So let me just quickly run this query. So my setup is I have 2 VMs, virtual machines on Azure, acting as nodes in my SQL Server failover clustered instance. By the way, I'm using SQL Server 2014 for this example. I'm using standard edition, 64-bit. It's running on Azure. It's a failover clustered instance. I've got SQL plus Azure as the SQL Server instance name. You might be thinking, so how come I'm not using this instance name in my connection string in Management Studio? Well, for one, it's primarily because the instance name is local to the network, whereas I'm connecting to an instance via the public internet. So this is the fully qualified domain name, and I configured this to use 2 shared drives, drive J and drive L, and I have SQL Node 2 currently running the SQL Server instance. And of course, you might be thinking, well, this is just a very simple example using Management Studio. Why don't I fire up a sample application, and I'll connect to it using the fully qualified domain name. I'll connect to the database, the same database that I was looking at. And I will just copy the query and run that query. So basically, this application is nothing more but a very simple application that connects to the database, connects to the server, and run this query. And so I'm going to connect to it. SQL. Oh, I totally forgot that this was by the way, I'm connected to this not using the credentials that I'm using locally, but using the credentials that I have on the Azure database. I'm using Windows Authentication, which has a domain account, and because there is no connectivity between the two, I'm using Windows Authentication. I'm using the credentials to connect to the application. That's why I'm using the run as command to connect to the database using my domain account and passing that through as my credential. But looking at this, I'm connected to my remote SQL Server instance on Azure, acting as a failover clustered instance. Not availability groups, because you could see that I'm only using standard edition for this particular case and connecting to the remote database. So I've just shown you how to connect to it. But on top of this, what do we really have? Recently, Microsoft released a KB article outlining the different server software that you could run on Azure virtual machines. And there's a lot of different Microsoft technologies, Microsoft Server applications that are supported. But when it comes to SQL Server, there is a limit to what is supported and what can be used. And this is an update that was recently added to the KB article. Volume level replication for non-shared storage. Keep in mind that when you want to run a SQL Server failover clustered instance, whether it's on-premise or on Azure or on any cloud provider, you need shared storage. But for this particular case, the shared storage is implemented via a Starwind virtual SAN, and that's where the whole volume level replication became supported because of these types of offerings. For highly available workloads, you have a combination of Starwind software plus SQL Server, Starwind providing the shared storage implementation, but from a VM point of view, the VMs don't actually access it as a shared storage. So let's walk you through how you deploy Starwind Virtual SAN on Microsoft Azure. Now, currently, there is a virtual machine template, much like how you would work with, SQL Server, SharePoint, CRM, or all the other different virtual machine templates available on the Azure portal. And Starwind have their own VM template available on the Azure Marketplace. So what you're seeing here is the Azure portal, where you can create a new VM and make sure that you're looking at the marketplace. Within the marketplace, you look at the compute option, and within the compute option, you look for the section that's named Azure Certified, and when you click on more, it shows you the different products that are certified to run on Azure. One of them you'll see there. You have Starwind Virtual SAN Classic that you could use for building your shared storage. Again, not the typical concept of a shared storage as we know of in terms of storage area networks, but in this case, it's displaying and showing the shared storage to the nodes in the cluster, the SQL Server Failover cluster, as we can use them. So let me just walk you through the process of creating a VM within the Azure portal. You got to provide a host name and then a username and a password to log into the virtual machines. Again, these are no different from your physical machines, except that they're getting created on the Azure portal. Pricing, it's all up to you how you want to use the pricing, but of course, you get what you pay for. The higher tier pricing, of course, is more performant, if there's such a word, or they're more powerful. We got more CPU disks. But what I wanted to focus on for this presentation is some of the networking configurations. The first one is the availability set, although I do make some changes on the operating system settings in terms of time zone and stuff like that. But the more important settings are, number one, your availability set. What I did was to create an availability set that contains all of the different servers that I have for my my SQL Server Failover clustered instance, which means for a traditional two-node failover clustered instance, you need Active Directory for it. Of course, I'm only focusing on 2 nodes because with Standard Edition, you have a maximum of 2 nodes for a SQL Server Failover clustered instance. So I have an Active Directory domain controller. I have 2 virtual machines for my SQL Server Failover clustered instance and grouped those into an availability set. As I was mentioning, for local availability, think of an availability set as a section or a locale where all of your machines are located. The next thing is the network configuration. And because we're dealing with a replicated form of storage where you can synchronize one storage to another, you need to have multiple network subnets. And what I specifically did for this case is I have multiple network subnets within my Azure availability set. A specific network is assigned for production traffic, which means that's the specific network that I'll use for running queries against my database, sending queries against it. But this specific subnet, the heartbeat subnet, is what I'll be using for my storage replication or for my iSCSI communication. The third thing here is the storage account. And what I did was I made sure that I have a storage account specific for this particular scenario. You can have as many storage accounts as you want. But again, for the purpose of keeping everything simple in my architecture, my storage account is the one that I use for building my availability set. That guarantees that everything is in the same region when I start building these VMs. Now, once you've set those up and once everything has been created, the optional configuration, the resource group, and the location becomes dependent on all of those settings that you create. And what I did, as I mentioned, is because I'm on the East Coast, I wanted to make sure that all my Azure resources are on the East Coast for local availability. If I want something for disaster recovery, I will create one that is on a separate region, and I can do replication in both. But again, for the purpose of this presentation, I'm focusing on local availability and fault tolerance using SQL Server Failover clustered instance with Starwind Virtual SAN as the shared storage. I was talking about the reference architecture that I mentioned earlier. I've got two virtual machines, and all of this are in the same availability set, which is in the same region, which is the East-US region on Microsoft Azure. These two virtual machines have two or more network adapters. I only used two network adapters for my specific infrastructure, primarily because my Azure subscription is limited by the number of virtual network adapters is limited by my subscription in that case. And I have my Starwind Virtual SAN configured and all of the storage built into it, and then created a Windows Server failover cluster for these. Of course, because SQL Server failover clustered instance requires the domain, an Active Directory domain, that's why these machines are joined to the domain. And then have SQL Server running on top of those virtual machines. So basically, the storage appears to be local because I don't have shared storage in this case. The storage appears to be local, and they're getting synchronized between those two servers, and SQL Server is running on top of it. Now, the shared storage is presented to SQL Server, but at any given point in time, only one server, only one VM in the cluster is acting as the owner of those storage. Let me pass over the presentation over to Max to talk about how the shared nothing concept in Azure works. Take it away, Max.
Hey, thanks, Edwin. So, as you see on this diagram we have on the screen right now, the concept looks really simple, but devil's in the details. So the idea behind Starwind's Virtual SAN here is to get every byte you write on server 1 on the left part of the diagram and mirror it with the second server on the right. And only then, when the data is mirrored between the servers, actually send a confirmation to the client saying that the data is physically written and secured on the storage. And you may think it looks like two separate disks at this point, but what we did, we used Microsoft multipathing driver, and technically we present this storage as a single resource to both servers. So if we get out of the technical details of this solution, as Edwin said, you solve the issue of shared nothing clustering capabilities without two enterprise licenses in SQL by using a third-party software, Starwind in this case, to mirror the local storage of your Azure virtual machines and present it back to the same Azure virtual machines as a single fault-tolerant storage resource. And on top, you configure Microsoft SQL Server always-on failover cluster instances and leverage the availability of a clustered solution. So right now you can be completely sure that this is something you can rely on, and even if the entire data center on the East Coast fails, you can fail over to another location with Microsoft Azure. So the idea behind the concept, you may have been wondering, okay, so Edwin didn't really tell why we save more than $10,000 on the deployment. So he got you some leads, but the idea is the difference between the pricing for Microsoft Edition, for the Enterprise Edition for SQL Server and Standard Edition is so big that dropping just one enterprise license saves you $10,000 instantly. And moreover, it saves you more than that, and in turn, you can move the entire infrastructure to Azure. You can install Starwind, configure SQL always on, FCI on top, and enjoy highly available application with zero downtime within the Microsoft public cloud. And with that, I would like to hand it over back to Edwin, because Edwin has a really interesting demonstration for you.
It's a good point that you brought up there, Max. Thank you very much for that. And again, one of the reasons I still recommend database mirroring, even though it's already been deprecated since SQL Server 2012, is really all about the cost of implementing a highly available solution. I mean, think about it. Price per core of an Enterprise Edition versus Standard Edition, big difference. Just by implementing a Standard Edition and putting Starwind on top of it and making it highly available through the solution cuts down on the cost. And I want to show that solution real quick, just to highlight what I've built with this particular demo. And again, I want to take you back to the reference architecture that I mentioned earlier, where, just going back a couple of slides previously, where I have two virtual machines with multiple network adapters, installed Starwind Virtual SAN on top of it, installed SQL Server on top of it. Of course, the provisioning of the storage to the SQL Server and to the cluster comes as part of that. So I basically just have 3 virtual machines on Azure in order to come up with the whole architecture. And again, you can have as many virtual network adapters as you want, because you want to have, number one, the replication of the storage between those 2 Starwind cluster nodes to be highly available with good quality of service. And on top of that, because SQL Server is still running on top of Windows Server Failover cluster, you want to make sure that your heartbeat communication and your production traffic and all that is still reliable. Depending, of course, on how you deploy your applications, you got to have a really good network definition as far as what traffic goes where. And so let me quickly, again, just show you how this entire thing has been configured on Azure. So this is I'm just logging in on my Azure portal up here, and just show you the different resources that I have using the Azure portal. And as I mentioned, what I have here is I have one domain controller, 2 virtual machines acting as SQL Server Failover clustered instance nodes. Everything is on my East US region, and that's one of the reasons why I built my availability set and my storage, everything in terms of the location, because I want to provide local availability. So let me connect to one of the virtual machines within Azure to show you how that works. So I'm connected to a server named, or in this case, I'm connecting using a fully qualified domain name with a port using remote desktop. So that's SQL Failover-ems.cloudapp.net. The port for this particular case is 630784 for remote desktop connection. And you might be wondering, why am I telling you all of this? Well, at the end of this, I'm going to tear down the entire architecture and rebuild everything again, all automated because of PowerShell, the beauty of PowerShell and redeploying that. So basically what I have is a 2-node cluster Windows 2 node cluster, SQL Node 1 and SQL Node 2. And these are simply local disks, clusters, local drive C and local drive D. And this disk contains all of the disks that I presented to my cluster via Starwind Virtual SAN. And of course, same thing, I have my SQL Server failover clustered instance. And this is what I was showing you earlier. Because I'm now connected locally to the machine, I can use the SQL Server failover clustered instance name instead of the fully qualified DNS name from connecting via the internet. So going back to the failover clustered instance, using failover clustered manager, I have my SQL Server failover clustered instance. It's currently running on SQL Node 2. And I have all of the different resources attached to it. You might be wondering, well, that looks like a public IP address and so on and so on. There's a lot of intricacies that are tied into building a failover cluster from within Azure, primarily, again, as I mentioned, on the networking side. Because number one, you gotta be concerned about security. You don't want to be broadcasting all the default public ports that your SQL Server instances are using, and that's also the reason why I'm using Windows authentication, because I want to make sure that only users that are authenticated within the domain can connect to the SQL Server instance. So as I mentioned, I've got 2 nodes. Currently, this particular node, SQL Server instance, is running on top of SQL Node 2. I can move that over to, let's say, SQL Node 1, just like how you would do it in your on-premise SQL Server failover clustered instance. Again, the big difference here is the way that the cluster was configured in terms of the networking, because you might be wondering, and I'll show you that once the whole instance is brought back online. So now my SQL Server instance is brought back online. If I look at the underlying Windows cluster and look at the IP address, you might be wondering, the IP address for my Windows cluster is not necessarily the same as the IP address or in the same range as, excuse me, my SQL Server failover clustered instance. Well, my Windows cluster is 10.1.0, whereas my SQL Server is 137.135, which is totally different. The idea here is because I wanted to connect to my SQL Server failover clustered instance via the internet, which again all depends on how you want to do that. I won't recommend that, but it's just one way of showing you how to do it. Is I'm connecting via the public internet, but Azure then forwards those requests to the internal IP address, and with all the port forwarding in place, I can be connecting to SQL Server instance via port 12345, and then it gets translated into port 1433. And that's what I mentioned earlier. As a SQL Server professional who deals mostly with performance tuning, querying, and application, a lot of these things are somehow outside of the scope of what we typically do. This is typically handled by a network engineer because of all the configuration setting. But the main thing that I wanted to point out, again, on top of the failover clustered instance is, number one, I'm using standard edition for this particular setup, and I'm using Starwind Virtual SAN to present the local storage as if they were shared storage, so that SQL Server can take advantage of that for high availability. So now it's currently running SQL Node 1. My SQL Server failover clustered instance is up and running. And let me connect back to this. And again, same thing. Run a quick query, select. Same thing that I did when I was connected to my Windows 7 workstation, which happens to be running in my local workstation. So now it has failed over from SQL Node 2, which was previously the one running the SQL Server instance, to SQL Node 1, and everything else remains the same. The real beauty of this is when Microsoft started announcing that they now support SQL Server failover clustering with all of the different features that come with it, on the assumption that you're using stuff like volume level storage replication for non-shared storage. That's a big thing for me, which again, as somebody who needs to, or who has a requirement to deploy highly available solutions, SQL Server solutions on on Windows Azure or Microsoft Azure, now I can do that without having to spend that much money in terms of licensing Enterprise Edition, because I can do it with Standard Edition. Let me quickly switch back to my slide deck. So I've shown you a couple of things about how you could use Microsoft Azure to build a highly available fault-tolerant SQL Server failover clustered instance using Starwind Virtual SAN on Microsoft Azure and the Microsoft Azure marketplace. The one thing that I would highlight at this point is when you go to the Azure portal and search for the Starwind Virtual SAN on Microsoft Azure Marketplace, you're tied in to a VM template with only a single virtual network adapter. So what I did is, for me to build a virtual machine with multiple network adapters, is I had to use PowerShell to build those VMs, not to use the template, and then install Starwind Virtual SAN on top of those VMs so that I can have multiple network adapters. Down the road, I believe that they will have the capability of creating a VM template from the Azure Marketplace and specify how many network adapters do you want for this specific VM. But again, as I mentioned, feel free to test drive that. If you have an Azure subscription, play around with it. I would also recommend even sign up for a test account on Microsoft Azure just to work on this. Again, more and more organizations are starting to use the cloud for not just all cloud solutions, but even a hybrid solution like high availability locally on-premise and disaster recovery for Azure. I want to open up the floor for questions and answers. If you have any questions regarding deployment of SQL Server failover clustered instances on Azure, whether it's failover clustered instances or even availability groups using Azure, but be it an all Azure solution where everything's up on Azure, or a combination of Azure and on-premise, or which is commonly known as hybrid, feel free to ask those questions and I'll be more than happy to address them.
Okay, Edwin, we got the first question here. The question is, do we need a witness machine for Starwind SQL cluster in Azure to operate?
Great question. So the question has something to do with using a witness, be it a virtual machine or whatever type of witness. Now there are two common types of witness that are used. You could use a disk witness. In this particular case, you could do so. You could create a shared storage, just like how we did in the previous version of Windows. Or you could use a file share witness. And the third one, of course, the one that I don't usually mention is the node majority. Why don't I specify, or why don't I recommend a node majority? Well, for one, you're paying what you're using. So spinning up a VM for the sole purpose of acting as a witness means that you will have to pay for that VM in terms of usage and compute and storage capacity on Azure, not to mention operational expenses like patching it, rebooting it, and all of that. Why am I recommending file share witness? Is because number one, it's cheap, it's available, as long as, of course, you're putting the file share on a separate machine other than the nodes in your cluster. In my demo, I had the file share witness on my domain controller. Not necessarily a good practice, but just for the purpose of showing you how to do that. again, it's available. The goal there is to make sure that you have quorum in the cluster to make sure that the cluster stays online when one of the nodes go down. Or depending on the version of Windows that you're using, if all of the voting members in the cluster go down, you have the ability to keep the cluster and SQL Server Failover clustered instance online and working.
Okay, and another question we have, can the on-premise server be at Enterprise Edition and Azure server be at Standard Edition and vice versa?
That's a good question. There's a couple of things to consider when you're looking at that. Number one, if you have an Enterprise Edition on-premise, what type of high availability solution do you have? Do you have availability groups or do you have failover clustered instance? Because here's the thing, whether you're using Standard Edition or Enterprise Edition, again, I'm not a licensing expert on this, but this is a rule of thumb. If you're under software assurance and you have one instance that's licensed, you are free to use an extra instance as long as all it's doing is acting as a standby, which means it's not doing anything. It's just acting as standby. You're not taking backups off of it. You're not running maintenance off of it. It's just acting as standby. So which means even if you're using standard or enterprise on-premise, you can get a free one on Azure. Of course, the challenge there, of course, is how do you want to build that? You have VM templates on Azure where I can spin up a VM and not worry about licensing at all because part of what I'm paying for on Azure comes with the license usage. In my particular example, I did not build the VMs off of the VM templates available with SQL Server installed because when you do so, those are all standalone instances that I cannot easily convert into a failover clustered instance, and that's one of the reasons why I built everything from scratch. So again, going back to the question of do we want to do enterprise on-premise and standard on the cloud or on Azure? Again, it all depends on how you want to architect that in terms of a high availability and disaster recovery solution. Now, here's my take on how that is being used is number one, you don't want to be in a situation where a failover for high availability is going to end up in the cloud where your application is on premise. And the reason I say that is even if you have a dedicated connection to Azure, and it really doesn't matter how fast that network connection is, it's still a lot slower if your application is on premise and your database is on the cloud. You might as well have both your application as close to your database as you possibly can. And that's one of the reasons why in the demo that I showed, my availability set and everything within there is within a specific region on Azure. I want them to be as close as possible to each other for local availability.
Okay. And question for me, I think, does Starwind Virtual SAN only appear as bring your own license in Azure? At this point, we have both. We have bring your own license, and we're also rolling out the Starwind Virtual SAN per hour model. It is currently certified, and we're doing the staging, so it should be available in Azure within the next 5 days, I think. And another question from our audience for me, how does the licensing of Starwind vSAN works? So for Azure, you just spin up the virtual machine. For bring your own license, you contact Starwind, and there is a license for 2 servers for highly available storage. Base license is for 4 terabyte served capacity, and then the next available license is Enterprise for unlimited served capacity within the 2 servers in virtual machines in Azure in this case. And if you require on-premise licensing, it works essentially the same, with one difference that we have slightly different Azure pricing. So you just need to get in touch with our sales representative, and they'll get you familiar with our pricing. Okay. And I don't think there are any other questions. So with that, I would like to thank everyone for attending our today's event. I hope it was informative for you. And I would really like to thank Edwin for putting together such a great presentation and a demonstration for our audience.
And I really, again, I'd like to thank everyone for attending. And I know I've covered a lot of content in this particular presentation, but if you're interested in learning more about Windows Server failover clustering in the context of SQL Server, again, for the purpose of providing high availability and even the combination of both HA and disaster recovery, I've actually created a course specifically for that purpose, because if you notice, there's a lot of intricacies going on just to provide a highly available SQL Server failover clustered instance. And I'm actually offering this class in the next month. The price for that class is about $1,295 US, but because you guys came in and took a look at this session, I'm going to throw in a $300 discount for that particular class. If you're interested, just use this specific code when you register on that specific website. That's bit.ly, that's 1I, capital IS, capital L9UT. And again, because SQL Server is now tightly integrated with and highly dependent on Windows Server failover clustering, there's a lot of things that we need to understand in order to properly design, architect, and deploy a SQL Server failover cluster or even availability group solution that's highly available for our applications. And if you do have any questions, again, regarding Azure or SQL Server high availability and disaster recovery, feel free to send me an email. I'll be more than happy to answer those questions for you. And again, thank you very much for attending this session. I really appreciate that.